Hi guys, today in this video we'll be discussing one of the problem from Leetcode, that is the running sum of 1D array. Now this array, running sum array, is also referred to as prefix sum array. The difficulty level for this problem is easy, and let's understand the problem statement first and the constraints along with it. So the problem statement over here states that you need to find a running sum of an array that is named as num. So you have been given as a nums array and you need to find the running sum. Now running sum is a definition. So if you see any element in a running sum array, let's say ith element is equal to sum of all elements from 0 to ith index in the nums array. So that means any element, let's say element 1 at index 1 in a running sum is equal to sum of index 0 and index 1 in nums array. So index 2 in a running sum array would be sum of index 0, 1 and 2 all three together. So this is how the running sum array is calculated. Now the problem's constraints that you have been given over here states that the nums array length can be up to 1000 elements in the array, and each element in nums array would range from minus 10 to the power 6 to plus 10 to the power 6. So this is the constraint. Now with this constraint you know what data type have to be used and probably what type of algorithm, so up to what time complexity you can go. So with this problem, this constraint, you can also go with n square, okay, because that won't give you time limit exceed, but I would recommend if there is a better solution we would definitely choose that. And over here we'll be discussing today with a big O n time complexity with space complexity as big O 1. Now let's start by understanding few examples and then we'll write the algo and then we'll write the code. Now let's take an example where I have a nums array which has 5 elements, namely 1, 2, 3, 4 and 15. So the resultant running sum array would be 1 comma 1 plus 2 is 3, 1 plus 2 plus 3 is 6, then 1 plus 2 plus 3 plus 4 is 10, and then 1 plus 2, 3, 4 and 15. This all would result to 25. This is the running sum array. Now let's try to understand this and try to find a pattern to solve this question in a very optimized way, which can be having a time complexity of big O of n. So we can have this time complexity. Okay, so what is the first brute force approach that comes to everyone's mind is brute force approach states that you'll run a for loop I is equal to 1 to n minus 1, and then inside this for loop you'll run a for loop for j which would start from 0 and go up to I. Now why I? Because you need sum of 0 to I, okay, and you'll keep adding sum is equal to sum plus array of jth index, and finally after this running sum of ith index is equal to sum, and you'll remove the sum to 0, initialize the sum to 0, and this. So over here if you see my time complexity over here becomes big O of n square, because in the worst case, that is last element, you are running for n elements from 0 to n minus 1 elements. So for n elements you would be running, so the time complexity becomes n square. So this is not the optimized approach. Now let's try to come up with a better solution. So for that, let's write a pattern, try to find pattern. So for that, let's see running sum of ith index, or the first index is nums of 0 plus nums of 1. Now I'll mention running sum as rs just to be faster. Running sum of sorry, this would get confusing. So rs of 2 would be nums of 0 plus nums of 1 plus nums of 2. Okay, now rs of 3 is equal to nums of 0 plus nums of 1 plus nums of 2 plus nums of 3. Now if you try to find a pattern over here, why I tried to write three such lengthy equations, if you try to see in running sum for third, I have running sum of 2. If I can replace this element with running sum of 2, so this equation is running sum of 3 becomes little short. It says running sum of 2 plus nums of 3. Now if you go ahead and see the same pattern in rs2 running sum 2, you will see this as running sum of 1 plus nums of 2. So that means rs of second is equal to rs of 1 plus nums of 2. If you go ahead and let's try to figure out for fourth index, that's the last index for us. So rs of 3 plus nums of 4. So now what happens when you start iterating from index 1? So once you are on index 1, you know the running, so this is the running sum of 0th index, definitely. So when you are on the first index and you are trying to find the running sum of the first index, you would definitely know the running sum of the previous index, that is the 0th index. So this value you definitely have, right? You have this value already calculated, and then you can just go to nums index 0, nums index 1, and you can just add these two and you got the index 1 of the running sum. When you go to index 2 of running sum, you already have the value of running sum 1 with you. Now you just have to add this plus this, so you don't have to iterate. So that means I have removed the dependency of this loop completely with my existing value. Okay, so now if I don't have this loop, you can understand my time complexity is reduced to big O of n, because now so basic algorithm that I would be writing for this is so for step 1 I would say uh, running sum of 0th index is equal to nums of 0, because for 0th index we don't have to calculate it. Now for step 2 we'll iterate from I is equal to 1 to n minus 1. So this is being key, and we'll write running sum of ith element equal to running sum of I minus 1 plus nums of I. just running this loop would result in the final running sum array, and you can just return this. Now, if you create a new array that is running some array, you create a space complexity that is having space complexity of big of n, because you have created another set of space for a same sized array. So this running sum would always have as many as element as there were in the nums array. So you create exact same size of block of memory in your RAM when you initialize the running sum. But what if I can remove this completely with nums array? Okay, so we'll just modify the step 2 to say that iterate from I is equal to 1 to n minus 1. That means this is exactly same what we were doing earlier, but with running sum array we are just replacing that with nums, because when I move forward I don't want to access all elements in the nums array. I just want to have the sum up till then and then the current sum. So I don't want to access any elements, exact element, the real elements that were passed to me as input for nums I minus 1. So from 0 to I minus 1, I don't want them. I'm just taking care of nums I minus 1, and that I minus 1 is also the sum of all elements from 0 to I minus 1. So that's why I can modify this array as well. If that is not specified in the question, you can directly ask your interviewer in case you have this problem in your live coding interview round. So this would result to reduce my space complexity from big O n to big O 1. So over here my space complexity is also reduced, and if you know, my time complexity is also big O of n. So we have come up with an approach which reduces my time complexity from big O of n square to big O of n, and we have come up with reducing my space complexity as well from big O of n to big O of 1. Now this part, space complexity, is depending on the interviewer's choice what he wants, but the time complexity depends on you. When you give an interview, if you write this solution, this is the best solution for this problem. So now let's go ahead and let's see the code for this, and then understand the time complexity in every steps. We'll map it to the code and see how the code is looking. Now this is my code that I have written in language Golang. Now why Golang? Because I prefer this language. You can use the logic that we have just discussed in any language of your choice, whether Python, Java, .NET or JavaScript, any language that you want. You can go ahead and write this same algorithm in those languages. Only the difference would come up with the syntaxes that are there for Golang. Now let's see the step 1. So if you remember, our step 1 was to mark running sum 0th index is equal to nums 0. Now when you are doing the calculation on the nums array only, you're not creating a new array, this step has no relevance. So I start with iterating from ith 1 to ith n minus 1. Okay, and I keep adding nums I is equal to nums I plus nums I minus 1. So, and in last, after running this complete loop, I return the nums array. So this is my step 2, and you see the time complexity is big O of n and space is big O of 1. So this is the code, and you can go ahead and try this code in the language of your choice, and in case you have some issues there, you can comment down on our video. We'll be happy to help you in those solutions as well. So that's it for this video today, and in case you like the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from Leetcode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.